Hi, this is Chris Armstrong from Siglent Technologies. Today we're going to talk about TDR measurements using an SNA5000A series vector network analyzer. This network analyzer captures impedance, gain, and phase information across frequency. It can then allow you to statistically analyze what it would look like with communication signals being pushed through that network. The instrument can simulate varying bit rates, levels. The instrument can even add jitter to this measurement. Then when it comes to the analysis, we're able to compare that eye diagram against mask tests, customized mask tests, and we're able to do this for a number of configurations for single-ended and differential devices. There's a complete app note on this under Siglent Solutions at the URL below. We're going to show a couple videos today, first starting with the calibration procedure, how to get into TDR mode and conduct a calibration, and then finally some results on a couple different cable assemblies that we've done here with a communication analysis procedure. Let's take a look. Let's run through a calibration procedure for TDR mode. First, in the math menu, let's go down to TDR and activate that. Now we see a menu here for deskew and loss compensation. Let's go ahead and go through that calibration procedure. So what we're going to be working with today is a differential two-port device. So we have to change our topology. Here's what we're going to be doing: ports 1 and 2 and ports 3 and 4 on two differential inputs. Now let's go ahead and do an open deskew measurement. Actually, for this one, I will leave our converter boards connected and just remove the USB cable we'll be testing. There we go. That process goes in 4 steps. Now let's go ahead to the next phase. Now we'll use our little through connector here and connect these to different ports in series. So for this, I'll disconnect my board. That's the easiest way to do this. And we'll start with ports 1 and 3. Go to the next, ports 2 and 4. So reconnect our throughput there. Now we want to do a 50 ohm load on all 4 of the connections. Since I just have one in my calibration kit here, I will do these one at a time. Connect the load. Leave it still. Configure that port. And so on with port 2. Additionally, port 3. And finally, port 4. All right, let's apply that. Now we can go next. Now we want to connect all of our devices, and so that it can do an additional length measurement. Now we're able to finish that entire process. Now we can go ahead and scale these
so we can see our data more completely on the screen. Now, we're in full TDR mode here. Let's go ahead and draw the eye diagram for this device. Excellent. So that's how you set up and calibrate the TDR measurements. Now, from this configuration, we can go ahead and do a couple additional tests. First, let's enable the mask test. So now we have a customized mask we can put in the center here. We can also go into the advanced waveform menu. This is going to allow us to add some jitter onto this signal. Let's do something like 0.02, like so. And then let's draw this eye again. So now, based on everything the system knows about the impedance and the setup of this device, it's statistically calculating what it would look like with a certain amount of jitter as a communication signal is being transmitted through. Let's see if it still passed the mask. So we've taken a 1 gigabit signal, we're passing it through that statistically, and we've added a little bit of noise. So you can see that jitter and frequency space is creating a wider band here in the crossings as that timing jitters, but we're still able to pass with this initial test here. We can do the same thing on a different cable as a comparison. Hook up my other cable, run this again. So this will let us see if there's any difference between these two cables in terms of their communication capabilities at a gigabit speed with a certain amount of jitter. So will they perform the same, or subtle differences in the impedance of the cables give you different results? All right, so still seeming to pass this test, but giving a lot more jitter. It's creating a lot more of issues across this band here. And we've brought, we have additional scaling on the top and bottom for this eye mask that we're getting closer to, which is why we have the expanded view here. So a great look at a couple different cables in a TDR eye mask test.